So welcome to the structural modeling November 3rd video session. And today we're going to be talking a little bit about open source structural modeling tools. It's kind of a framework to really talk about the overall development and components of structural modeling. But before we get into that, we have a new member that I'd like to give her an opportunity to just introduce herself to the group. So Rafia, would you like to say a few words?
Okay. Hi everyone. Myself Rafia, and you can my full name is Rafia Zaman, and I'm from Bangladesh. Recently, I have started my PhD PhD studies in Austria. So I belong to University of Graz, but my affiliation with is the institute is Institute of System Sciences, Innovation and Sustainability research. So basically, I am doing on sustainability oriented research and with a particular focus on energy transition in developing country. So yeah, so this is all about myself, and I'm really looking forward to it because I'm just a new baby to this PhD stuff. So I just started at the end of September. So yeah, this is all about myself, and I like to do research on energy issues and this kind of things. And now I'm really getting interested with this system complexities issues because I belong to this institute. This is called System Sciences as well. So yeah, so this is in short. I am Rafia. Thank you, and I'm very happy with this group.
Thank you, Rafia. That sounds like you have a very interesting topic and are well prepared to explore this area in detail. We have today, we're going to be talking a little bit overview of some work that was done by John Warfield in social technical systems over a long period of time, starting back in the 70s, going up into the early 2000s. One of the aspects of John's work was that it was focused mostly on the development of technical systems. So the unified program planning was basically started to control operations, large-scale operations like a national shipbuilding type of program or a national program of building roads or things like that. So that's very large-scale program planning, where you have a large-scale social system that is designing and deploying a large-scale technical system. And that was kind of the first structured approach that was put together. And really, many people that use what they call interpretive structural modeling today really focus on the unified program planning. And the key characteristic of that is that really unified program planning can all be done mostly by hand and with hand graphics. You don't need to have the logical computer support that you need in interpretive structural modeling. Well, you can uh, apply and develop software to do unified program planning. It was really mostly a manual technique for planning. So there are folks, mostly in India, that use this type of technique, and they call it interpretive structural modeling, but it's really very much unified program planning with a few variations. So what's happened over a period of time is these three techniques: unified program planning, interpretive structural modeling, and interactive management. They've kind of lost their distinction between and among themselves, what they are, how they're the same, how are they different. And so this is a key characteristic of what we need to do we need to talk about when we start talking about creating open source structural modeling tools, is really start making these distinctions, developing these distinctions, so that we can clearly communicate about these topics. So as I said, there's the three components. There's unified program planning, the interpretive structure modeling, and the interactive management piece. All right. And of course, the interactive management piece was the one that Warfield and Cardenas, they developed last. And so it included components of the unified program planning and the interpretive structure modeling. And it kind of wrapped it in an overall process that had designated products and outcomes. And that is pretty much the interactive management techniques are fairly well described in the Handbook of Interactive Management, which is available online in a PDF, and you can also get that as a hard copy and get it in as available. But once you look at the interactive management and you start taking a look at the details, it's a very rational problem-solving, basic problem-solving, value development type of system process. It really reminds me a lot of the large-scale systems engineering and program management techniques that are used by very large-scale aerospace corporations worldwide. So worldwide supply chains, things like that. It seems to be very much a similar type of activities. And it's a recursive type of process where you have a planning phase, a workshop phase, and a follow-up phase. Of course, then you can do these recursively, where you can have, the first activity has a planning phase, a workshop phase, and a follow-up phase. And then you can have a follow-on activity that has the same three, and so on and so on. So it is made to be adaptable and is very general. And, in reading and looking at the materials, not only in the Handbook of Interactive Management, but also in the Science of Generic Design, it's important, I think, to understand that IM is grounded in the managerial functions of intelligence, design, and choice. So those are really kind of three things. It's like, okay, we have intelligence, we have information, we have value systems, we understand how things should, work, we have some ideas. That's kind of intelligence, and that's a wide, amorphous, large group. And then design, so then the group needs to actually make some decisions about the specific task at hand, and then come up with alternative designs. So we have a range of designs that might work, and then choice. Then somehow you need to choose what you're going to do at that particular that phase, right? You need to have some kind of choice. And that's kind of a general pattern that you see implemented in many, many large-scale systems and system production, system operations. And of course, basically the idea is to create an organized, structured collection of tasks and activities focused on producing the required result and what you want to have happen. And what this does, of course, is it allows you to clearly identify templates, patterns, communication processes to augment and facilitate your activities. So I think, and of course, as we go forward through this, one of the things that's very important to think about is cost. And so the idea of what does it cost to do these types of activities? And are these activities in interactive management, are they isolated, standalone things that you only do every once in a while? Or do they become a part of your ongoing operation? Do you have the capability to actually do this all the time with different groups of people and different on different aspects of the problem and the problem space that you're dealing with? Well, that's kind of an overview of the space we're going to be working with. One of the key drivers, one of the key aspects of open source or interactive management or structural modeling is you need really to have a computer logical computational unit when you get up to the point where you're doing ISM. You're just doing the manual planning techniques with the unified program planning. Most of that can be done manually. However, it would be better to have a computer program to support that. And there are computing systems today that could easily be adapted to that. So there are a number of computing systems that have been made available over the years, but they're all closed source, and it's not clear how they work. We've gone through and evaluated a number of these software systems and the mathematics and the requirements behind the ones that we could get in these algorithms. And these two links here basically are the are links to a repository in GitHub where we talk about, we have the information associated with our analysis of existing software and applications. The NCOSE 2015 is a, well, let's just see if we can go here and see if that, nope, that didn't come up. But anyway, if you follow that link, it takes you to a GitHub. And 2015, that NCOSE conference, we gave 3 papers and a tutorial on complexity reduction and how you might want to use these particular techniques. And then the SMP, the Structural Modeling Project, the second GitHub link that has the software. We've done an initial proof of concept, logical software component that's there. Now our next task, what we're going to do now, is we're actually going to expand the tool set, the structural modeling tool set, open source structural modeling tool set, and expand a little bit more, but we've selected Vue.js as a technology to implement this in. And I've done some smaller little proof of concept ideas have been demonstrated, but no major architectural piece yet. And so now what we're doing is we're going to really discuss the architectures, what needs to happen functionally with a larger scale software architecture that will be expandable. So we really want an open source software architecture that's modular and is allowed to, designed to allow incremental design and deployment so that we can actually adapt the software in a reasonable manner. So kind of the gold standard that we've been bouncing, that we compare the software to, the software functions, is the GMU ISM software that's kind of detailed on Appendix 2 of a Handbook of Interactive Management. We've looked at those. The software that we have on GitHub implements those functions. We've looked at those functions from a number of different aspects and have found what I believe are some fairly interesting insights that at least should be mentioned before we go forward and continue to develop software. And we'll talk about those more in detail in a little bit. But to talk about these things in detail, we developed the augmented model exchange isomorphism, provide a standard framework for relationship categorization and evaluation. So what the AMEI does is it provides us a framework within which we can clearly communicate the logical properties of any specific system relationship. And once you have the AMEI, then you can combine words or prose and the AMEI, structural graphics and the modeling, to be very precise about what you mean by a relationship. There's a number of natural language relationships that are not very precise. Part of is one, but using the AMEI, you can clearly define what you mean and assign the logical relationship to part of, which it's either part of is reflexive, asymmetric, and transitive, or part of is irreflexive, asymmetric, and transitive. And then, of course, we have added a scoping factor to transitivity, where transitivity is either going to be local or global. With those concepts, you can clearly define and clearly communicate exactly what you mean when you say part of. If you just use the natural language words part of, there's a lot of uncertainty. And so these other aspects that are associated with the augmented model exchange isomorphism allow us to very clearly communicate the logical and mathematical aspects of the relationship. So in the Handbook of Interactive Management, the software that was there had a do model, a do class, and a do priority commands, which again, as I've mentioned, we already implemented in the software that's on GitHub as a proof of concept. And these are very interesting types of commands from let's say a measurement or a measurement scale aspect. And we'll talk about that a little bit more later on and what that means. But we have measurement scales, or whether we're talking about number scales where we have nominal, ordinal, interval, or ratio. This is very important in your calculations and the type of valid calculations you can make in your modeling. And as I said, later on, we'll talk about a little bit about the differences in the measurement scales and type of numbers associated with the do class, the do prior, and the do model. So I think that is one area that I haven't heard discussed in any detail, and I think it's important. And it's important when we have the outcomes from that. So here's some of the things we need to do. Our concurrent activity threads are we really need to develop the requirements for our software tool set, and people that would want to use it, we would like to get some feedback from that. And then the software architectural design, that work is ongoing. The work is on GitHub. Software code production, again, that's be on GitHub. We're going to use Vue.js and the type of software ecology that's developing around Node.js and JavaScript in general. And then, of course, we'll again have unit integration and functional tests associated with that. So we're going to slowly develop a production process that will give us production quality software in the end, but it'll take a while to get there. So here is the, of course, the requirements for these three commands that were in the GMU software. And this is a, this is actually a screenshot of the software that's available on GitHub and from the structural modeling project. And what we have is strict order, so select the appropriate integrated approach. What we have is a strict order, or one object per class, strict order, one or more objects per class, and then cluster objects into classes. So essentially the do class was clustering. The do prior did the strict order, one or more objects per class. And there was another example in Appendix 2, which was the do model, but it did the strict order, one object per class integrated. So that these three functions here that are available on GitHub, these will allow you to create these types of system structures. And this was kind of a proof of concept of the software and the mathematics. What we found when we went through and did this work on this particular model and this particular software was that we could actually use a binary search algorithm, and it would be just as effective or even more effective than the classical ISM algorithm. So the classical ISM algorithm worked, but it was developed at a time when binary search wasn't really that well known. They were just kind of developing that as a computer science or a mathematical concept. And so it wasn't applied here, but basically the classical ISM algorithm appears to do the same thing. So that's what we implemented, the classical algorithm in the new software. We will implement binary search because it is just as efficient and maybe even some areas more efficient computationally than the classical algorithm. So you'll go ahead and implement this in the new, but this is only, again, the logical component. Doesn't manage any of the other activities around it, specific components for it. And so what we need to do from a requirement standpoint is to figure out, okay, actually, when we're looking at interactive management, what are the phases? We have 1, 2, 3, 4, 5, 6 different phases. And what type of general activities do we need, right? And so as we can see here that every phase needs persistent data. We need to have some way to persist data from the information that's developed during each phase. So that's kind of a database. And then we say uses a logical software. So the logical software we just talked about, we can see that only the idea structuring uses the logical software keys. None of the rest of them do. And then track users. Well, every case you need to track users. And of course, the last three, the idea structuring, interpret structures and adjust them, you really need to also track their votes. So this, just in general, implies a standard content management system with an interactive database that authenticates users. You have to be able to track the users, so you need to authenticate them, identify them, know information about them and how they relate to the problem at hand. The logical software component, that will be available for the activities when you need them. And of course, persist data, it'll have a database that actually works with this information and provides it in the form necessary to support the activity. So in general, what this says is we need to have a system that authenticates users, authorizes users, persists data for every step in the process, but also has the logical software available. And to do that, what probably needs to happen is that the processes from the Handbook of Interactive Management need to be encoded into the software process so the software can actually guide people through it, and then it will have the database in the background, all of the authentication and authorization in the background, and the logic in the background. It's just the general way that we're going. Of course, we talk about the standard ideas and the standard processes in interactive management. There's idea writing, and basically that's what people kind of get organized around a specific problem. They generate ideas, try to get things working. Then the nominal group technique is also something you can do. It's can be used to generate ideas, adjust ideas, classify them, and it's a way of organizing a group of people to get them focused and to work in a, let's say, a more expeditious manner than if they were just kind of let go by themselves. And of course, both of these techniques would benefit from custom software. Interpretive structure modeling, of course, can be used to structure ideas, interpret ideas, and adjust them. And it has a logical component. Of course, what we're thinking about now is we were going to either use an SQLite database, which is very portable as a component to any of these systems that we use. And that may change, but I really don't think so. I think SQLite 3 is going to be one of our primary components that we will use for the persistent data, for authenticating users. There's a large number of features that go with it. It's in the public domain, so it has a lot of attractive features to it. Initial software architecture will just focus on phase 2 processes and the creation of an embedded database to support the IAM processes. So really what we're going to generally do is take the IAM processes and outline those steps and workflows in the software and make it so that it's adjustable and adaptive. It said here the initial software system is based on Node.js, Vue.js, and SQLite 3. And we'll have the module that contains a database so that we can register the authentication and authorization of users, and also have a database that persists data. And we can identify each of the users and what they're doing. Okay. Those will be administrative tools for the administrator and a number of other just standard features. Okay, so now we'll get back to the conceptual relationship representations, and this is where I was talking a little bit about, I said earlier about the different measurement scales and what's going on there. So, and it's based on the augmented model exchange isomorphism, but it's also based on the concepts of different kinds of numbers. And people that have been following the development of the structural modeling tools know that in the AMEI and in the logical components, we really don't allow for a partial order. And so if you think about that, ordinal is is the type of numbers that you can use to place things in order. And nominal is the types of numbers that you can name things, but they don't put anything in order. And if we look back at the GMU ISM software, we look at the very fundamental thing that's going on there. If you look at clustering and classification, there we're just using the nominal scale. We're using the names of things. What are the names of these things? We're saying with our information, with our knowledge base, with our personal knowledge base or the group knowledge base, we are taking these names and we are clustering them into things that are similar or the same classification. So there's no ordering, there's no interval involved, there's no ratios involved. This measurement scale for clustering is just knowledge that we have about names and classes, and then arranging things in groups. So that's fundamental. Nominal scale is all you're using in clustering. Ordinal scale then is what we use when we're placing things in order. We're ordering things. Now, ordering, we're talking about value scales, the measurement scale of some kind. We don't know the interval between these, what the distance is between objects, but we know that we're placing the objects in the right order. So these are two completely different types of numbering systems. They're two completely different concepts in measurement. And when we look at this and think about the partial order, we'll see that the partial order mixes these two. And when we've reviewed the literature in complex systems approaches, some of the errors that we find that were conceptual errors that were perpetrated and distributed throughout their processes were based on mixing the nominal and the ordinal scale, so that people would take a nominal measurement and they would apply order to it, because partial ordering does not clearly say which is nominal and which is ordinal. And so there's numbers of examples of where nominal and ordinal scales are actually mixed and give you the wrong answer, give you nonsense answers. So it's important, I believe, to evaluate the types of scales, types of measurements we're going to be doing with this software, and be very clear about the areas that they apply and the areas that they don't apply. And we can use this then as a kind of a defensive mechanism so that our software will have less of an opportunity to generate nonsense. It might generate nonsense, but not because of these specific issues. So we've seen these in the past, and what we want to do is eliminate these. And so we want to talk about them now. So the nominal scale is interesting again in as far as Warfield's work, because Boolean values, true and false, are nominal. They're just names, true and false. And one of the things that Warfield did in his augmented Boolean algebra was he extended Boolean values to the ordinal scale by adding the greater than or less than operators. So we can use the augmented Boolean operations from Warfield to address systems that have nominal and ordinal scales. But you have to be very careful and understand what you're doing when you're doing that, and also understand what mathematical operators are valid. And so you know that your answers are going to have a chance of being valid. So this is an example of carefully extending a measurement scale to provide insight into a system's structure. And this is a very important part, I believe, of Warfield's work that's basically just overlooked. And And it's something that we're going to emphasize and something that we're going to have in our software and highlight what's going on. Now the interval scale, you're able to actually make some kind of distinction about, oh, what is the value? And I know Rafia said that she'd worked with the analytical hierarchical process,
Yes.
and which says you need to make some kind of ratio from 1 to
Yes.
9.
Yes.
And people are very bad at that.
Yes. It's
They,
true.
yeah, they have, as people simply can't do that very well. And Jack Ring, who presented the last couple of sessions, and Dave Ullman are interested in adding a Bayesian type of modeling capability to this tool set, which I think is an excellent idea. But again, that's interval. We're going to interval and ratio now when we're talking about things like AHP and Bayesian model generation. So we need to know that we're not relying just on people's values, because we know that people are very bad at doing that.
Mm.
So that is one of the reasons that with the augmented interactive management approach that we're putting together here, that we're going to create an interface for something like KDpedia. So for the people like Janet who are in the ontology group and in the artificial intelligence group, there's been some folks that have been working on a knowledge-based systems for the last 2 or 3 years, and they open sourced, well, they announced their first open source version, I think a couple of weeks ago. But what it does is it is a system that allows you to query vast stores of knowledge. And so when a group needs to actually have information about interval or ratio, it's not just their opinion, it's not what they feel, because people just can't do that. They're very bad at that. But if they can query the sources that have got measurement, they've got experiments, they've got experimental data, whatever is available for them to say, oh, this is the value of that interval, or this is the value of that ratio, right? Then that type of information will allow us to carefully integrate interval and ratio capabilities like Bayesian modeling or AHP. I'm not sure that AHP has that much value. It has, in my opinion, some real issues. But anyway, I think that probably Bayesian types of generative modeling approaches mixed with a Kalman filter would really help a lot. But these are the types of things that we're thinking about this architecture will be able to support. So we're going to augment the traditional human knowledge base from interactive management. We're going to augment that with modern, sophisticated artificial intelligence knowledge acquisition from vast databases. And then we will use that to support the interval and ratio measurement scales in our interactive management approach. And so this is kind of the vision of what we can do with by augmenting the classical approaches. Okay. And so then let's say, as we're going on here, talking a little bit more about just some of the aspects of the software and the measurement scales in the Handbook of Interactive Management. It said it used a nominal scale and an ordinal scale. And the clustering example, of course, is just nominal, and heavier than, of course, is ordinal. And then partial order mixes those two. And as I said before, that's really, in my view, what I've seen is really a source of tremendous logical error. But then the other thing that really needs to happen, and what we've developed some other concepts to go along with the AMEI, and one of them is scope, like scope transitivity, where you have global scope or local scope. And that's very important when you're talking about like part of. You have to be able to say where is the conceptual boundary scope of transitivity, and so with the AMEI, we're able, and our scoping rules that we put together, we're able to do this, and then we can very clearly communicate where the transitivity boundaries are. Okay. So as we go through those, these are just ideas and things that we've looked at. Highlight the idea that actually Warfield took Boolean algebra out of the nominal scale, put it in the ordinal scale. I don't think people appreciate the power of that enough. It's extremely powerful. And the new process interfaces and representation. So really, we're going to use these ideas of measurement scales and inquiry approaches to design the software architecture to support not only human knowledge and values, which is very important, but also to properly integrate that with established scientific knowledge and measurements that, that are available online from publications that allow us to do interval and ratio. So with that, I'll open it up for discussion.
How are you doing on a timetable for all of this, Joe?
How am I doing on a timetable for it?
Yes.
Well, it's there's so the Vue.js software is there. It's I can what I do, because I really don't have I'm not getting any user requirements, right? So if I had some user requirements coming in, people that really had some ideas about what they wanted to see first, second, or third, then I could, evaluate and organize that. But all that said, so I'm just basically proceeding at my own pace and picking which ones I want to do. So I'm doing the Node.js and the Vue.js. I've pretty much hacked out a database graphic front end that allows people to, authenticate, track, and do things. In doing that, I decided that I picked the probably not the best technology. I've reviewed that technology a little bit. I'm going to switch, but it goes along. I get work on it every month. I mean, every week, and develop the requirements, develop the software. So, and of course, as you can probably tell, it's a very large scope. The vision is huge.
Oh yeah.
So that the whole thing will probably never be done, but architecture just kind of keep going, right?
I mean, I think the value of open source and not having black boxes, or having minimal black boxes, is a crucial part of the this whole work that you're doing. So in no particular, is there some reason that you've gone with a traditional SQL database rather than a graph database?
Oh, The reason I went with SQLite is simply for overhead reduction.
Right. Okay.
SQLite is an embedded database, so it doesn't need any.
Right.
It
Gotcha.
doesn't need any servers or anything like that. I just put it in place.
Right.
And but the database itself and the architecture is going to kind of be plug and play. So if you want to do a graph database, right?
Yeah.
The idea is that there'll be an interface, and okay, if you don't want to use SQLite, then you can use, MySQL, you can use Maria, you can use Firebase, you can use whatever you want. You can use Neo4 for J or whatever. Right?
Exactly. Okay. All right. Well, that's fair enough. I mean, an interesting use case, because Rafia introduced herself, I went and looked at their webpage, the University of Graz, and on their front page they have a very nice graphic of the systems sciences.
Yes, e-textbook.
Yeah, and an e-textbook, and so I mean I'm very interested in that, Rafia, and I'd like to perhaps when we sign off here and we're not broadcasting, we could just have a chat before you leave, because it would be good to know a little bit more about that. But I was thinking that in your work in power transfer and power or energy work in Bangladesh, and sustainable energy production and so on, that given the many possibilities that exist, the kind of documentation process in the e-textbook would be a good first starting. I mean, on energy processes in Bangladesh and or sustainable around the world, would be an interesting first step to some kind of program planning, unified program planning, whether it be or IS, whichever kind of approach you take to think about priorities in the work that you're doing. I mean, it would be, or even getting sort of stakeholders in Bangladesh involved in discussions, because the other topic we've talked about, Joe, is the ability to do this over the web.
Yes, it's.
Can I interrupt?
Yes.
I just need to convey you like a few things. For example, basically my background is a business, like a business administration,
Right.
and I started working like for my master's thesis. I started like I got interested in this kind of energy issues, and that's how in 2015 I started my energy related research and something like that. And the thing is that I'm not a particular like engineer or like I don't have any technical background in a sense, but I like decision making theories because there is not too much like a quantitative perspective, or I would say like I can understand those mathematics quite easily. So yeah, that you mentioned that the e-textbook in our website, like in our university, like a SIS website, so that is developed by our system science Professor Manfred
Right.
Funsak,
Right.
and his supervisors. So like it was like they have a very good plan, because it is also used for our different courses. Even I am also studying system science courses because it is my precondition for my PhD studies, because
Right.
I have a different background. So the thing is that the idea you told me, so basically it was a very good idea, because like the acknowledgement or the knowledge, that means for example in my first research, so there is like one particular dimension is more about like a knowledge creation, learning and knowledge creation. But in Bangladesh, yes, exactly, we don't have this kind of even like a more educated person. For example, we have done masters and everything, but even even though we do not know how to use a solar PV technology, or we don't have sufficient knowledge uh, how to integrate into our everyday practice or something like this. So it is actually a very good idea, but I don't know how can I incorporate it in my, because I'm not a like a system scientist, but I am trying to learn some methods. But really I don't know, because I don't have any like computer language knowledge as well. So I am still like I'm trying to learn Python because it is mandatory for my course. So this is how I am. So I really don't know that with my shortage of background how much I can do.
Oh, I
But
think you can do an awful lot. Don't be limited by your perception of your background, is what I would say. I mean, the very fact that you are here today, that you're
yes,
listening to this conversation, which
yes,
in many respects I think is, if you look at the history of this, it's significant work and it has enormous potential, as Joe, um, just alluded to. And I think it would be wonderful to think about applications in sustainability issues, particularly as it relates to energy, and particularly as it relates to countries like Bangladesh
yes,
that have got a host of challenges.
yes,
And the one I'm particularly familiar with is sea level rise.
yes.
And
Yes, that's true.
so, and that's Joe, that sort of comes back then to, you're talking about applications or priorities or use cases. I mean, is there some way we can help, or we can say this is what we'd like to see first or something? How would that help you in your development efforts here, and then help someone like Rafia or myself who's sort of looking at these in terms of methodologies and approaches and applications?
Well, I think that that's one of the things that would be helpful would be to just start with the unified planning process, because
Right,
unified program planning can be done by hand. You don't need any computer background, right?
right,
And you can look at those specific steps in transition. It has inputs, outputs, uh, uh,
And
all
feedback.
kinds of. Yeah, it has a very well-defined matrix transition process that you do by hand,
Okay.
and by doing that, it prepares you for understanding the matrices and the interpretive structural modeling piece.
right. So
Yeah.
it's a good background and training.
Yeah, so I would
Um,
start with unified program planning because you can do it by hand, and you can look
Okay.
at that, and And then once you understand what those components are and what those are doing, then you can look at the ISM. And then with that background, you can probably have a good chance of using the software that's on GitHub, or I could help you figure that out.
Okay. Thank you.
Yeah, and by that time, we might have other software available.
Oh, okay. Yeah, thank you for that, because I was also like I was wondering how can I use this one, because normally before like race day I try to uh go through number of literature. So actually they just describe the methods, but they didn't say like uh how can I really apply that one. So that's why I really get confused, because for example, if I go for expert interviews, so in that case, so as you said that nominal scale, I guess the most of the literatures they use the scale like nominal AVO or zero, something like that. Either it has a relationship, or factor A influences factor B, or either way, or maybe both way, or there
Yeah,
is no. So this is one kind of. So I was also like when you are discussing about this scales, and then I was thinking about, okay, so this is more about nominal, but there is no ordinal part, because it
yeah.
just says, and then the major part that I was confused, because I did this kind of expert interviews already. So and when I like aggregate all the expert judgment, because I need to have one particular matrix. So and then how can I combine this one? So then I found like one paper they mentioned it could be group consensus, or it could be either majority rule.
Well,
So
okay, so there's when there's been a technology around as long as interpretive structural modeling or ISM or program planning, there's a lot of history that go on. And one of the things I just want to caution you about, especially what you were mentioning, first of all, the people in India,
Yes.
They use a modified type of unified program planning approach, and they
Okay.
use a type of modified planning approach that was different than what Warfield came up with. Unfortunately, what happens in these areas and during Warfield's time is there was people that misinterpreted his work and had a lot of political power and
Okay.
published books, and basically there's made some very fundamental mistakes.
Okay.
I We have published on those, but the stuff that you just talked about, the VIO and all that,
Yes.
yeah, that's not Warfield's work. That's a misinterpretation, in my opinion. But if you learn the program planning piece, then you'll understand how it's different. And that's a self-similar matrix. And the self-similarity matrix piece, what happened there was Warfield actually went to Mitsubishi shipyards in Japan, and
Yes.
he taught them the unified program planning. And then two things happened from there. One was a house of quality, that the Japanese took unified program planning and twisted it into the house of quality, which came back through MIT and out through that aspect. And
Okay.
then the other part was that a couple other people twisted UDP and with the self-similarity matrix. So if you're confused by the literature, you're paying attention, because it's very confusing. And that's why people have a difficult time with that. And that's why we're doing what we're doing. Okay?
Okay. So like exactly what could be my starting point? Like as you said that I need to go through like I have already started reading that book, but for example I have like a little bit deadline like ahead of myself. So it's like at the end of November I need to present my first topic with like in detail with my
Okay.
methods.
Yeah,
So
now that I know a little bit more about you and what you're doing, let me get a few papers on unified program planning.
Yeah, please.
thank you.
Yeah, John Warfield was also the editor of the IEEE
Yeah, explore.
publications, and he published quite a bit. And so I have copies of those. I can give you some pointers on what it means and just kind of examples of how to do it. And so that would be, why don't I do that? We'll
Yeah,
just
I think that's a great starting point, Joe, because you know you've framed this now, and also for people like me that are not, we're not computer programmers or Rafia. We're interested in participative, collaborative,
Yes.
open decision making that
Yes.
is wholly transparent and is as unified and as comprehensive as possible, and
okay.
manageable and doable and quickly too. I mean, that's the issue about coming back to my time frame. She's got a time frame end of November. We're all getting older. Time ticks by. It would be good to see what we can do.
Okay, what I will do is I will take an action to send out to the list some papers on unified program planning. We have about 2 minutes left. The next session will be November 17th. We're looking for someone to take the lead on that one, and maybe at that period of time, if someone wants to discuss some requirements for whatever they want to do or so forth, would be a good time to do that. But we'll wait to see who steps up for November 17th. And this has been very good. I was hoping that by starting to separate these things that have been all kind of mushed together, that people would find a handle that they could get a hold of, right?
Right.
Because the folks in India do what they call ISM, which is really modified UPP.
And just one addition, like they also like Mr. I guess the name that is Mr. Shushil, I guess, like he already introduced another version of ISM that is called Total ISM.
Yeah, yeah. So anyway, so you see that there's lots of issues. And so what we need to do is very carefully define what these things are in
Yeah.
a non-political way. To
Right.
say, okay, here's the steps, this is what happens, this is how this works.
Go back to the source.
Yes. Because it has been mauled a lot over the years.
Yes, and it's not transparent, so you don't know what's going on.
Exactly. There you go. So, okay, I'm going to stop the broadcast now. Thanks, everyone. I'll leave it up so you can talk.